So, hello everyone, and welcome back to our channel with the GFG POTD streak of day 115. And before starting the channel, if you are new to this uh, tutorials, then please like, share, and subscribe so that we can learn, grow, and maintain our streak together. And also, before starting the question, I would like to say that I have completed my recursion series on my this channel. So it's highly recommended for you guys so that you must visit this how the recursion thing happens, and then we'll proceed on with the trees, graph, and DP, right? So let's come back to the question, and today's question is arithmetic number. It's an easy category question. So if you have read the question and able to guess the multiple approaches as well, then it's very good. Else we'll see what the question says and we'll code it. So given three integers a denoting the first term of an arithmetic sequence, c denoting the common difference of an arithmetic sequence, and an integer b, okay, and an integer b, you need to tell whether b exists in the sequence or not. Return 1 if b is in the sequence, otherwise return 0. So it's like actually a very mathematical problem if you say. So arithmetic sequence. So let's see what the so let me explain you what arithmetic sequence is. Arithmetic sequence is nothing but there is a sequence of numbers. Let's say 1, then 3, and then 5. So if you see that each and adjacent number have a common difference of 2, right? Similarly 7, 9. So these numbers are known as the arithmetic sequence, right? Where each and every adjacent numbers have the same common difference. Okay. So for a equals to 1, 3, and c equals to 2, the output is 1, while explanation is 3 is the second term. So okay, if I add the common difference that denotes as c in the first term 1, then it will become 3, right? So that is saying that 3 is the second term of the sequence starting with 1 and having common difference 2. Similarly, for the second test case for 1, 2, and 3, you can see that the first term is 1 and the second term itself will be 1 plus 3 plus 4, which will exceed the value of b. So that means the this b will not be present in our sequence, right? That's right. The first term was 2, and the common difference, let's say d is 3. So the second term will be 1 plus 3, that is 4. That is 4. And the second term itself exceeds the value of b. So that means b will be never reaching in our sequence, right? So you have to say that return 0. So what could be the naive approach, or let's say the brute force approach of this question will be that what is an arithmetic sequence that we move on proceeding ahead in the rightmost direction, doing plus d and plus d in each and every step, right? So let us do this. Let us do the same thing. So I will say that int x is equals to a, my first term, and I have to reach till point b, right? So I will say that while x is less than equals to b, right? What I will do, I will check that if we have reached the point x equals to b, then that means the point b was reachable and I will return 1, right? If not, I will just do this increment at each and every step of plus d, right? So I will say x plus equals to c. Here the common difference is denoted in the question as c, right? And I will just close this while loop, and I will say that if I exceed the value b, like in this case, the second term itself was 4, it exceeds the value b, and the while loop will stop after the second iteration, and I will say that return 0 in that case, right? So let us code this solution and see if it works or not. But before that, let's move ahead with the constraint that what's the value of a, b, and c. So a, b, and c lies in the range of 10 power 9. So a, b, and c have the constraint of 10 power 9 less than equals to minus 10 power 9. So that means we need to do some more things in our code. So that is the importance of the constraint here. Before I hit the submit button, if I just read the constraint once, then I visualize that I need to do edit something in my code, because you can take the negative numbers also. If you take the negative numbers, let's say minus 2, minus 9, and minus 7, let's say, right? So will it return 0 or it will return 1? So minus 2 will be the first term, minus 2 minus 7 will be the second term, right? Right, I guess. So it should return true, right? It should return 1. But our code will not handle it correctly, because it will say that the x was initially pointing to minus 2 and it is less than equals to minus 1, which does not holds true, right? The equality minus 2 is greater and the loop itself will stop here. So how to tackle this situation is that one thing is that we can maintain the while loop for negative and positive integers separate, but that will be like repeating the two while loops, right? So instead of doing that, I can just say that if math.abs of x is less than equals to math.abs of b, right? Then it holds true, right? So it will compare that 2 is less than equals to 9. It will say yes, right? Then move on. So it will move on with minus 2 minus. So it will like x is equals to nothing but minus 2 minus 7, that is minus 9. And the if statement will compare it and it will return minus 1. Yeah, so it will handle this negative case as well if I just include math.abs here in this while loop, right? Okay, so that's the pseudocode, and I highly encourage you guys to pause the video here now and try to code it yourself, right? I have exactly given you the code and the logic, so let's do it. So let's move ahead with the coding section now, and we will code it. So let's say we'll do x is equals to a, and I will mention a while loop that while math.abs of x is less than equals to math.abs of b, right? We have to reach b, right? So until we reach b, we just at each step we will iterate with the addition of the common difference. So whenever at the moment I will reach b, I will say that that this is possible. I will return 1, and the increment I am supposed to do is x plus equals to c. This is nothing but x is equals to x plus c. And if that's not the case, if we never able to reach the bth point in our sequence, then I will say return 0. But what is the time complexity of this solution? So how many times I'm moving here is I'm moving c times to reach x to b. So let us visualize what will be the worst time complexity for this. So what I'm doing is I'm moving from x to b with the increment of c, right? And the worst case is like if I move in the increment of just 1, right? And s and x, let's say, start from 1, and b is, let's say, the worst as 10 power 9, right? I've assumed the numbers in such a way that we will encounter our worst case complexity. So as we can see that you have this number 1 and you are moving till a number which is 10 power 9, and you have taken the c as the common difference 1, right? So you can directly see that it will take a time complexity of 10 power 9, right? Which is obviously 10 greater than 10 power 8, and you will get a TLE if you code this approach, right? So if you do not able to understand this 10 power 8 logic, I have already made a video on the time complexity constraint. You must visit that. So it's just a 6 to 7 minutes video. It will be a very enlightenment information for you guys. So you must saw that it will be flashing up here now, and you can go and see through and come back. So we have visualized now that if we submit this solution, it will definitely give us the TLE. So, but let's just first compile and run to see that if our logic holds true for each and every test cases here, right? So it definitely handles the positive integers. So let's now check it for the negative ones. So I will say minus 2, minus 7, and let's say minus what? It was 9 or what? It was minus 2, minus 9, and minus 7. Okay. Let us compile and run again, and then we'll hit the submit button. So great, we are getting an answer, correct? So let's hit the submit button and we will verify if the TLE comes or not. The TLE will this should definitely come, right? Okay, so great. Our purpose is served here now. We saw that why the TLE come, and now we have to optimize it. And I have already explained you guys, if a solution is giving you TLE, then you must have coded in greater than 10 power 8. That is why you are getting TLE, right? So in order to optimize it, the first point is eliminate the recurring steps. Eliminate the recurring steps. So that is the reason my videos are long. And if you will be able to bear with me till the last, I can guarantee you that you will definitely gain some information, right? And if you're new to this channel, if you like my teaching way, then please subscribe it, and we can learn and grow together for that thing. So eliminate the recurring steps, recurring, or let's say repeating steps, right? Repeating steps. Eliminate it, or I can say optimize it, because you cannot eliminate it because you have to use that constraint, that integer which is getting from this repeating steps, and you have to use this, right? As you can see here, I have to use this thing. I have to see that each and every iteration what is happening, right? So how I can eliminate or optimize this repeating step? In the repeating step, what I'm doing, x plus equals to c. I have to remove this step and I have to make some optimization as well, right? So now let's come to the mathematical part. the mathematical part, right? That was the brute force, and now you'll think in the smart way, or in the, let's say, more educated manner. So if A is given and you have this D given, so then you can say in the arithmetic expression that the nth term will be A plus n minus 1D, right? You can say that the basic maths. So what can I say is that if you have let's say a number starting with 2 and you have a common difference of let's say 5, right? So 2 plus 5 will be 7, and 7 plus 5, okay, and 7 plus 5 will be 12, and 12 plus 5 will be 17. Now if I say that what's the difference between these two numbers, and let's say B was given as 12, right? This was A, this was B, and let's say this was the C number given to you, right? And it was checking that if 12 come in the series. So what can I say here is, what is 12 minus 2? It is 10, right? And this difference is nothing but it is a multiple of D, let's say xD, because as you can see the difference here was D and difference here was D again. So each and every integer, if you pick either any two inches, either this one or this one, or again this one or this one, you will get difference which will be the multiple of D, right? So if I just verify if this difference, if difference percent C, the common difference is given to me in my question, is equals to 0, then I can say that B is part of our sequence, right? I can say that. But before proceeding ahead with this point number 1, the intuition here, let us see, because the constraint was given as the number should be negative also. So let us see that can we derive any solution between A, B and C if there exists an equality. So what could be the cases that if A is greater than equals to B, A is less than equals to B, and the third case could be like if A is equals to B. There is no other case possible here, right? So if A is equals to B, then I can directly say for this case, is return 1. I can directly say for this, right? So I need to handle this cases now, this case and this case. So if I say if A is greater than B, then I'm talking about which test cases? I'm talking about which test cases? I'm talking about that let's say what? A is 1 and B is 5, and you can say the inequality holds. And let's say B is 5 and A is 1, the inequality holds like this, right? So this is A and this is B, and D is nothing but let's say D is 2 here. Okay, so I can definitely say now that if A is 5, the first term is 5, and the term which I'm getting after 5, that is the second term or the third term, is getting reduced, then I can say that my common difference is must be negative. Then only I can do something subtraction in my first term and I can reduce the number, right? Similarly, if the first term is negative and it is increasing, then I can certainly say that the C must be positive, right? C must be positive. So that means it will be negative and it will be positive, right? As you can see here. And let's say C was equals to 2 minus 2. And in this case, it was plus 2. And as you can see now, from 5, it will go to 5 minus 3. 5 minus 2, that is 3. And 3 minus 2 will go to 1. And you can see that the 1 is possible here, right? And you will say that, yes, true. The B of the possibility of 1 can be made. Similarly, for 1, if you will do plus 2, it will be 3, 3 plus 2, 5, and you can see that the B is achievable in our sequence. So what can I say here now? So that means I have to maintain an if statement, something like this, that if B is greater than A, right, and then C should be greater than 0. So this is my first case, or I'm now writing the same things in code perspective, right? So it should be like A greater than B, and then C should be less than 0, right? Then only this logic can be applied, right? Because this is applied for a generic sequence, right? And this ensures that you are in a sequence, that you are in an let's say if these are the conditions, then I can say that this is a valid AP. This is a valid AP if these constraints satisfy, right? If these constraints satisfy. So that is what I have written in an if statement, and I will just say now what I have to do, that I have to just take two numbers and I have to differentiate it, right? So this was the first number, this was the second number. What I did, second minus first number. So if I do B minus A, if I do in this case B minus A, it will be 1 minus 5 that will be minus 4, and I will check it with modulo of c, that is minus 2 here, right? And it will give me 0. And you can see that actually 1 was achievable. So if that's the case, I will return true. Similarly here, I will say that b minus a, the second term which I'm the second or the third term, I don't know, which I have to achieve, I will pick that term 5 and I will minus it with the first term, and I'm definitely sure that this will be the multiple of x into some common difference, right? So I will just make this number and I will divide it by actual RD, which is 2 here, and it will be competing to 0, right? And we will get our answer. So let us code this thing, and so I highly encourage you now to pause this video and code these steps by yourself, right? So yes. um, okay, so I hope you are able to code this approach. So let's discuss the global steps, what we need to write. So these were 3 global steps, right? So first I have to handle if a equals to b, just return 1, directly 1. I do not have to see if c is positive, greater than equals to 0. It could be anything, right? I do not care. If the first and second term is given both as same, you have to return 1, right? Because you don't have to do anything now. The given b is itself equals to a, right? So let's code this thing now. So let's reset the editor, or maybe I shouldn't have reset it. Yeah, let's just comment down this thing. Yeah, great. So the first case was that if a is equals to b, right? Then I will say that return 1. That's it. The second case was the second two cases where the AP holds true, right? For our logic will be that if b is greater than a, and then c should be greater than equals to 0 in this case, right? If that's the case, or the second possibility is if a is less than b, right? And c should less than 0. C is nothing but the common difference here. That is it. So now this guarantees me that this is a valid AP now. This is a valid AP. Now I can deduce or I can apply my logic here, that the difference of any two numbers in a sequence will be the multiple of common difference. So let me write it that. Let me write it for you. Difference of two numbers in AP will be equals to the multiple of common difference, right? And the two numbers should be from the first number should be the left in the rightmost, and then in the what rightmost minus leftmost, right, or let's say the number should be the first pick from the right direction, then from the left direction, right? So I will say that if b minus a, right, if b minus a percent the common difference percent c is equals to 0, that means the number b is achievable, is present in our sequence. Else if that's not the case, then for rest of the cases just return 0. Let us hit the compile button, run now, and we'll see for ourselves that our logic holds true for each and every test cases or not. Okay, so we may have done some mistake. Let me verify it again. Okay, I have written the same cases twice. In the both cases I have made b greater than 0, so it should not be the case, right? And now let's compile and run again. Yeah, great. So we are on the same page with the solution as well as the required solution. So let's hit the submit button now, and before hitting the submit button, so the time complexity of the current code will be O of 1, because we are not using any for loop here. We are just using 3 if statement, right? And we are comparing some things. We are finding the modulo, so it would be O of 1. So let's hit the submit button now. So great, you can see that all the test cases passed successfully. And let us discuss the optimization we made. So the first brute force technique was that we did plus d and plus d in each and every iteration, and it takes O of n, let's say. and O of n was nothing but 10 power 9, which was greater than 10 power 8, so it gives us the TLE, right? The method 2 was we eliminate the recurring steps, right? The plus D steps, we eliminated it, and we derived the test cases that what should be the possible inequalities possible between A, B, and C, and using 3 if statement we are able to achieve it. So that would be O of 1. So great guys, if you're able to bear with me till last, so you sure you have gotten some maybe a knowledge not about AP because everyone knows AP, but about how we approach a problem. How if the interviewer asks me to optimize it, how do we go in a specific direction to optimizing it, right? What should we look in our previous code? We look for the repeating statements and then we try to eliminate and optimize it, right? So the main motive of this channel here is to teach you to learn together that how are we able to intercept any problem and solve in a particular direction. Few last thing that's my DSR repository. You can start and fork to get help with the source code, as well as you can connect me here on Instagram as well as on LinkedIn for any doubts and guidance if you may have. And if you still have any uh, doubts regarding this question, but I'm sure you will not have. But if still you have it, anything, any recommendations, any suggestions, or any feedback you want to add, then I like encourage you guys to mention down in the comment section, and we'll meet again tomorrow for the next video, that is day 116. Till then, keep learning, keep growing, and bye bye. Take care.